morning, children. In today's class, we are going to learn problems about important limit based on trigonometry. Limit theta tends to 0. Sin theta by theta is equal to 1. So, how are we to derive this formula? Limit theta tends to 0, sin theta by theta equals 1. Consider an unit circle. What do you mean by unit circle? The radius is 1. So the value OA, OC, the points on the circumference. So OA is 1, OC is also 1. We consider O as the center of the circle. Now consider the angle AOC as theta, as we need theta in the question. Complete the triangle where AB is the tangent. We consider three areas now. The big triangle OAB, the small triangle OAC, and the sector OAC. This green line, this red circle, arc, and then OC. So we have three areas to be considered. For the big triangle, it is a right angle triangle because the radius and the tangent cutting at 90 degrees. When I have a right angle triangle, the area is half base into height. OA is the base, which is the radius of the circle, and that is 1. Height h, how to find out? To find AB, AB is opposite side for theta and OA is adjacent side for theta. Combining this, we have tan theta. What is tan theta? Opposite side AB by adjacent side OA. But OA is 1. So I can cross multiply. AB, the height h, is nothing but tan theta. Substituting in the formula, I get half into base is 1, height is tan theta. So the area of the triangle OAB is tan theta by 2. Consider the sector OAC. The radius being 1 and the angle included is theta. What is area of sector? It is half radius square into angle between. The radius being 1, 1 square is 1. So half into 1 into theta is simply half theta. Consider the small triangle OAC. Now it is not a right angle triangle. When I know the two sides, because they are radius of the circle, OA is 1, OC is also 1, and the included angle. We have the formula for area of triangle from trigonometry. Half this side into this side and sine of the included angle. So half side is 1, the other side is also 1. So 1 into sine theta. That reduces to sine theta by 2. When I compare the three areas from this diagram, the smallest triangle is OAC. Next comes the sector OAC. Next comes the big triangle OAB. So what we say? Area of triangle OAB is definitely greater than or equal to the sector, and the sector is definitely greater than or equal to the small triangle OAC. So we have found out the three areas which we have written. All the 2's we can cancel. And now tan theta can be written as sin theta by cos theta. My question is sin theta by theta. So what we do? Throughout, let me divide by sin theta. So sin theta cancels, theta by sin theta. Sin theta by sin theta becomes 1. Taking reciprocals, because my question is not theta by sine theta but sine theta by theta. As I take reciprocals, 1 by cos becomes cos, theta by sine theta becomes sine theta by theta, and here I cancel reciprocal of 1 is again 1. Whenever I take reciprocals, greater becomes less. Remember, 8 is greater than 7. But when I take the reciprocal 1 by 8 and 1 by 7, I should obviously remember 1 by 7 is bigger. So the inequality reverses whenever I find reciprocals. So in this question, as I take reciprocals, greater symbol becomes less. Now the question is, I want theta tending to 0. So every term we take limit theta tending to 0. Here this is my question. When theta tends to 0, 1 is a constant, so I get 1 only. Constant is not affected by the limit. Here I put 0, cos 0 becomes 1. So we get limit theta tends to 0 sine theta by theta. This limit value is 1 and this limit value is also 1. This answer is in between these two. So we can apply sandwich theorem, what we learnt in the earlier video. Whenever three curves, say f of x, g of x, h of x, are one over the other, the curve that is in the middle will tend to the same limit what the upper and lower curve tend. So here, this curve and this curve, as I reduce, they become 1 in the limit. Obviously, using sandwich theorem, the middle term should tend to the same limit 1. And so, replacing theta by minus theta, because theta need not be positive in all the cases. If theta is minus, here I get cos of minus theta is cos theta, so the limit there is no change. Here also the limit there is no change whether it is theta or minus theta. In the middle, sine of minus theta by minus theta. We know sine of minus theta is minus sine theta. Cancelling the minus symbol, I simply get sine theta by theta. So we conclude whether theta is positive or negative. As long as theta is in the interval minus pi by 2 to pi by 2. But I eliminate 0 alone. Why? Theta is in the denominator. Whenever we have something in the denominator, ensure it is not 0. So in this interval minus pi by 2 to pi by 2, eliminate 0 alone. So for all the remaining values of theta, as theta tends to 0, we get sine theta by theta is 1. Let us do some exercise problems based on this special trigonometric limit to understand this better. Limit theta tends to 0, sine theta by theta is equal to 1. Consider this problem 7. Limit x tends to 0, sine alpha x by sine beta x. To apply this formula, what all should I consider? Here what comes should come in the denominator. Theta means down also theta. And the theta should tend to 0. So in this question, I can write limit x tends to 0. The numerator, I have sine alpha x. To apply the formula, I want alpha x in the denominator. Whenever I divide, I need to multiply also. Here, I have sine beta x. So, I need beta x. What is coming here? Beta x. If I want beta x down, let me multiply by beta x. Because x symbol will confuse, let us put into. Now, the numerator and denominator, I can cancel x. What is left out? Alpha in the numerator, beta in the denominator. And I have limit x tends to 0, sine alpha x by alpha x, denominator sine beta x by beta x. We know very well, I can split limit for the numerator as well as denominator. So put the limit for the numerator separately and the limit for the denominator separately. Whenever x tends to 0, alpha x also tends to 0. Similarly, whenever x tends to 0, beta x also tends to 0. Now, the numerator is exactly fitting the formula. Sine of what comes in the denominator and it tends to 0. So, the answer is 1. Similarly, sine of what? That is beta x comes in the denominator and beta x tends to 0. So the answer is denominator, already there is a beta and this answer reduces to 1. So the final answer is alpha by beta. Simple problems based on the limit theta tends to 0, sine theta by theta is equal to 1. We proceed on to question number 6. Limit x tends to 0. Sine cube of something, denominator also x cube is there. The very first idea in limit, I can bring the power out. So I can write it is the whole cube of what? Sine x by 2, denominator x. Now to apply this pattern, whatever comes with sine should come in the denominator. So what I do? Multiply by 2 and divide by 2. Multiply by 2 and divide by 2. So I have the step like this. Now bring this 2 out. How does it come? It is in the denominator and it is with the power 3. So the numerator nothing comes out. Now what is my answer? Limit x tends to 0. Sine x by 2 divided by x by 2, the whole power 3. I can bring the whole power outside the limit also based on our properties and limits. Now the entire thing, when I apply the formula, sine of what comes in the denominator. Also, whenever x is tending to 0, x by 2 also tends to 0. So it exactly fits and it reduces to 1. The whole power 3. Here 1 divided by 8. 1 cube is 1 into 1 by 8 gives rise to 1 by 8. So we have simple problems which I can still more make easy by applying limit theta tends to 0. Sine theta by theta is equal to 1. Exercise 9.4, question number 8, limit x tends to 0. Tan 2x by sine 5x. Limit theta tends to 0, sine theta by theta is 1. In the similar lines, we can work out limit theta tends to 0, tan theta by theta is also 1. Sine theta by theta. In my question, I have sine 5x. So denominator I want 5x. So multiply and divide by 5x. Similarly, tan theta by theta. So tan 2x is given. Multiply and divide by 2x. Now, as I combine this tan 2x by 2x, I want for the formula to be applied. Similarly, sine 5x by 5x. You can cancel this x and x. 2 by 5 being constant, keep it out of the limit. It is not affected by the limit. The numerator we can put limit separately and for the denominator we can put separately. As I know, tan theta by theta becomes 1 as theta tends to 0. If x is tending to 0, 2x also tends to 0, 5x also tends to 0. So, the numerator becomes 1, the denominator also becomes 1, and the final limit is 2 by 5. Question number 9. Limit alpha tends to 0, sin alpha power n by sin alpha the whole power m. As before, let us apply this formula. Limit theta tends to 0, sin theta by theta is 1. So what comes with sin? I need it in the denominator. Alpha power n. Let us multiply and divide. The denominator also, I have sin alpha. So alpha I will multiply and divide. Now, to apply the formula, I want only this term. So keep alpha power n separately. Denominator, I want only sin alpha by alpha. Take alpha out, it goes out as alpha power m. Now I can apply limit for the numerator, limit for the denominator. This being alpha, let me combine alpha power n minus m. The numerator reduces to 1 because we apply this formula. As alpha tends to 0, alpha power n tends to 0. So the numerator becomes 1, the denominator becomes 1, leaving us only this term. When alpha is tending to 0, alpha power n minus m, what happens? Suppose I have alpha power 7 minus 7. Here n and m are equal. What is my answer? 7 minus 7, 0. So I get alpha power 0, that is 1. So when n and m are equal, alpha power n minus m is my question. So when n and m are equal, I get alpha power 0, that is 1. When I have 8 minus 7, now n is greater than m. I get alpha power 1. When I take limit alpha tends to 0, it becomes 0 power 1. So my answer is 0. So when n is greater than m, for example, we have taken 8 and 7. My answer becomes 0. Now, suppose I have n less than m. I get alpha power 7 minus 8. Now, n is less than m. It becomes alpha power minus 1. As I put limit alpha tends to 0, I get 1 by alpha because it is alpha power minus 1. And as I put 0, 1 by 0 tend to infinity. So we have the three cases. If n is equal to m, the limit is 1. If n is greater than m, the limit is 0. And if n is less than m, the limit tends to infinity. So we have taken and written the answer for the three different cases. Question number 10. Limit x tends to 0. Sin a plus x minus sin a minus x by x. As we apply the trigonometry formula, it is sin a cos x plus cos a sin x. Same way, sin a cos x minus cos a sin x divided by x. There is minus symbol, sin a cos x cancels. Minus into minus is plus. Cos a sin x, again cos a sin x. Adding, I get 2 cos a sin x. Denominator, there is an x. Associate the x with sin x. 2 cos a can be retained out being constant. We can limit x tends to 0 sin x by x, and we know this reduces to 1. So 2 cos a into 1 gives rise to 2 cos a, and that is the answer. Question number 12. limit x tends to 0, 2 arc sin x by 3x. In the limit formula, we have sin theta by theta reducing to 1 as theta tends to 0. Similarly, sin inverse of x, which is nothing but arc sin x, divided by x also becomes 1 as x tends to 0. So taking 2 by 3 out of the limit, I just put the limit for sin inverse x by x. As x tends to 0, it reduces to 1. So the answer is 2 by 3. Question number 17. Limit x tends to 0, 1 minus cos square x by x into sin 2x. In all these questions, if I just put the limit value, I get 1 minus cos 0, that is 1 minus 1, 0 by 0 pattern, which I will call indeterminate. And so, I need to reduce using algebra or trigonometry. Here also, if I put 0, I get 0 by 0. So, in all these cases, we arrive at indeterminate type. Even in the 10th problem, as I put x 0, I get sin a minus sin a 0. So, this is also 0 by 0 type only. So, to avoid that, we reduce using trigonometry. Now, in 17th problem, 1 minus cos square can be written as sin square. X as it is. Sin 2x, the formula 2 sin x cos x. I can cancel sin x and square. I am left with sin x by x, 2 cos x. I know this reduces to 1 as x tends to 0. So, limit of the first term, half is not affected by the limit, keep it as it is, and limit of the second term. The first term reduces to 1, half as it is, and here wherever x comes I can just put 0. Cos 0 is 1, so the entire limit reduces to 1 by 2, and that is the answer. Question number 14, limit x tends to 0, tan 2x by x. We recall the formula, limit theta tends to 0, tan theta by theta is 1. If I have 2x, I need 2x in the denominator. So multiply and divide by 2. This full thing reduces to 1. Bring 2 out of the limit. 2 into 1 gives rise to 2. 13th problem. 1 minus cos x by x square, limit x tends to 0. If I directly put x becoming 0, I get 1 minus cos 0 is 1 by 0. That is 0 by 0 pattern. Whenever you have 0 by 0, I call it as indeterminate. So let us use trigonometry to reduce the problem. 1 minus cos x formula, 2 sin square whatever is here by 2. So 2 sin square x by 2, denominator x square. Bring 2 out. This is having square, denominator is also having square. So the square I can bring out. Sin x by 2 by x the whole square. To apply the formula, sin theta by theta is 1 as theta tends to 0. I want to bring x by 2 down. So multiply by 2 and divide by 2. I need only sin x by 2 by x by 2. This 2 is an extra term, so bring it out. 2 square will come out. So 2 and square I can cancel, giving rise to 1 by 2. We are left with limit of this trigonometrical ratio. When x is tending to 0, x by 2 also tends to 0. Apply the formula. Sin theta by theta reduces to 1. As I substitute, half into, this full limit becomes 1. Half into 1 is half, and that is the final limit value. Question number 20. Limit x tends to pi, sin 3x by sin 2x. As I substitute x as pi, I get sine 3 pi by sine 2 pi, both are 0. So 0 by 0 is indeterminate. Therefore, let us apply the trigonometry formula. Sine 3x is 3 sine x minus 4 sine cube dx. Sine 2x is 2 sine x cos x. Every term sine x is present. Let us divide by sine x. Here it becomes 3. This is 4 sine square x. This is 2 sine x getting cancelled, giving us cos x. As I divide every term by sine x, we are left like this. Substitute the limit wherever x comes. Let us put pi. It becomes 3 minus 4 sine square pi divided by 2 cos pi. Sine pi 0. So, 4 sine square pi becoming 0. Denominator cos pi is minus 1. As we simplify, I get 3 by minus 2, that is minus 3 by 2. Question number 27, limit x tends to 0. Sin x into 1 minus cos x by x cubed. As before, 1 minus cos x can be written as 2 sin square x by 2. I want sin x by x. So x cube I can split x into x square. This let me combine sin x by x and this let me combine. Taking the square out and bringing the 2 out. It is 2 here. Limit x tends to 0. Sin x by x. The entire answer becomes 1. Here bringing the square out. I need to get x by 2. So multiply by 2 and divide by 2. Bringing this 2 square out. 2 in the denominator, the whole square. 2 square will come out. As I cancel 2 and square, it reduces to 1 by 2. I am left with limit x tends to 0. Sin x by 2 by x by 2. This full answer becomes 1 by the limit formula of trigonometry. 1 the whole square gives me 1. 1 into half is again half and that is the final limit value. Question number 28. Limit x tends to 0. Tan x minus sin x by x cube. As we know, tan x can be written as sin x by cos x. Already there is sin x in both the terms. Sin x is common. The remaining terms limit copy as it is. Only the numerator we try to simplify. Taking sin x out, it is 1 by cos x minus 1. Taking LCM, it is 1 minus cos x by cos x. Now we have sin x by x cube into 1 minus cos x by cos x. As I know, sin x 1 minus cos x by x cube. Sin x 1 minus cos x by x cube. From problem number 27, I can put the limit as 1 by 2. What is left out? This cos x alone in the denominator. So put the limit separately for this. This answer, as I put x 0, 1 by cos 0, that becomes 1. This entire answer we can work out like this, which brings about 1 by 2. 1 by 2 into 1 is 1 by 2 and that is the final limit.